use continuity to evaluate the limit. And we have the limit as x approaches 2 of arctangent of the rational function x squared minus 4 over 2x squared minus 4x. Now, arctangent is an inverse trig function, so we know that it's continuous on its domain. And the rational function is going to be continuous on its domain. However, x equals 2 is not in the domain of this rational function. So we can't just use direct substitution. However, we can use the theorem that we saw earlier that says that if we're taking the limit of a composition of functions and the outer function is continuous, we can move the limit inside. So we can write this as arctangent of the limit as x approaches 2 of that rational function. And then to evaluate that limit, we can try and simplify that function. And the way that we're going to do that is by factoring it and seeing if any factors cancel. So the numerator is a difference of squares, meaning we can factor it into x plus 2 times x minus 2, because 4 is 2 squared. And then in the denominator, we can pull out a GCF of 2x, which leaves us with the leftovers x minus 2. And then we have a common factor in the top and bottom that we can cancel, x minus 2. And it's not a problem to cancel that because when we're looking at the limit as x approaches 2, that specifically means we're looking for x values near 2, but not equal to 2. And these two factors are only equal to 0 at 2. And we're specifically not looking at 2, so that means that they're not equal to 0, so we can cancel them out. And then we have something simpler inside, so we can write this as arctangent of the limit as x approaches 2 of x plus 2 over 2x. And then we can use direct substitution here, because we don't get a 0 in the denominator. And so when we plug in 2 here, that gives us 2 plus 2, which is 4, over 2 times 2, which is also 4. So that's just going to be arctangent of 1. And if you know your arctangent well, that's going to be pi over 4. So that whole limit of the composition of functions ends up being pi over 4. And let's take a look at the graph of this function, because why not? Here we go. That is an interesting function. We've got a jump discontinuity at 0. I didn't know that it had a jump discontinuity, so I'm glad I took a look at that. It's really neat. And yeah, we can see if we look at what's happening as x approaches 2, we have a limit that's a little bit less than 1. And pi over 4 is a little bit less than 1. So that matches up.